Hey guys, we're looking at practice problems 1.10, jumping right in here with number 1 from that section. And we're looking at a scale problem of a scale drawing, so we need to set up our ratio. Our ratio is always going to be in these situations of what we draw compared to what it is in the real life. And they'll give you these scales. They'll say, when you draw it, it's 1 inch, and for every 1 inch you draw on the paper is equivalent to something else. So this first park that we're looking at is 1,000 feet per inch. And the second park that we're looking at is 500 feet per inch that you draw. And what I like to do with this problem here, just to kind of prove the point, is let's just pick like an arbitrary length of a park. Let's say that we have a park, an easy number to work with, 1,000 and 500 is 5,000. So let's say that we have a real park that we measured it to be 5,000 foot long walkway or something. We've got a path here that's 5,000 foot from this point to this point. And if I drew it on this map right here, well, since every 1,000 foot is an inch, it would be 5 inches. That pathway would be 5 inches on this map because 5,000 feet would have to get multiplied from 1,000 by 5, and 1 times 5 is 5. So that's pretty straightforward. Now, if I drew it on this particular map over here that is 1 inch to 500 feet, 500 goes into 5,000 10 times. And so if I wanted to draw a 5,000 foot parkway on this map, it would draw it 10 times longer than 1 inch, which is 10 inches. So even though the number is smaller in the scale than the number in this scale, 10 inches is a longer and a bigger map of this park's walkway than this one. So the larger map is this one right here. This one is larger because the map would be longer than the other map.